Hey guys, today we got a brand new tutorial on how to make a top-down space shooter. So yeah, this is going to be really awesome. And yeah, so the first thing that you want to do is just open up a new project in Unity3d. Don't download any of the assets, we don't need any of those for this. We might be making some assets of our own in Blender, we'll just have to wait and see, but this video unfortunately is going to be mostly scripting. So yeah, it's kind of a downer, but still, we are going to be doing this in 3D, so Unity 3D in 3D. I mean, there's a 2D option too, but we're going to be doing this in 3D, even though we're probably going to end up using orthographic mode, so it's basically 2D, but yeah. Anyway, the first thing you want to do is just create a new game object. So we want a cube, let's call this cube player. And we'll make a sphere too, so the sphere is going to be like our asteroid. Okay, right, awesome. Camtasia just crashed already, so let's just hope that doesn't happen too often. Yeah, so we should have our player and the sphere. So next we're going to want to create a C# script, and we're going to be doing camera movement. So let's just call this camera position. And plus the on position, and it will click that to, and monodevelop's basically just well, it's assembly C#, so it's just a place to write it, you know, like Notepad++ or whatever. Public class camera position, so this is the class that we're accessing. Void starts, use trend initialization, blah blah blah. And the first thing we're going to want to do is transform.position. Basically we're doing this because if we look in the inspector here, then we have transform, and inside transform we have position. I don't know, I'm looking at the player. So it's the same thing anyway. The only difference is here x is 0, y is 1, and z is -10. So we'll go ahead and write that in. So equals new vector 3, and don't worry, I'll explain what a vector 3 is in a second. So 0, 1, equals -10. Yeah, it's probably -10. Okay, so a vector 3 is basically 3 directions in the 3D plane. So even though the game is going to be pretty much 2D, so we're going to basically be ignoring the z-axis, it's still cool to have depth in the game, so it's the -10. Also, that's going to determine the distance of the camera, like from the player's perspective, or from the player's ship at least. So yeah, that's why that's there. And we'll go ahead and make a new variable too. Variables are always fun. So speed integer, I'll call it 1. So basically an integer is a whole number. We've named the variable and we've called it speed and assigned it the value of 1. I don't know why that's... Do you have an error? Really? Oh yeah, sorry. Equals 1. Okay, don't forget the equals. And also the semicolons on the end of lines of code are, well, basically we need them. It just means that that line of code stopped, so if we wanted to run onto a new line, we could do. Yeah, so we're also going to make the camera move. So to do that, we just want to go to transform, translate, and we don't need an equals for this because it's going to be constantly updating. So we don't need a new vector 3 either because we've already got the vector 3. Oh god, I spelled vector 3 wrong. Okay, there we go. Vector 3 dot up. So basically that means it's going to be moving up. Times speed. Don't worry about the times thing or the asterisk. It doesn't actually mean times. It just means together. So vector 3 with the speed so it's going up with the speed. Also, we want it to do it in real time. Don't worry too much about time.delta time. That basically just means it's going to be doing this in real time. So to check the script works, just go to main camera. Oh yeah, attach the script too. That's something I always forget. So you can see now that it's appeared down here. And play. So now the y-axis is changing, so we're going up. And basically, what this is going to let us do is, if we want a background, we'll be able to put one in, and we can move across the background constantly. So the game, you know, it has a bit more of a flow to it if we do that. So I believe that's it for the camera. I mean, if we've got anything else to do with the camera, we can just come back to it. So we'll make a new C# script, and we'll call this one player. Yeah. So in player, show it to mono develop. There we go. Okay, so the first thing we want to happen is we want the player to spawn at a point of origin. So we don't want him in the middle. We want him to be kind of at the bottom. So let's say, yeah, let's say -3. So it's the same thing we did here, only this time it's 0, -3, and then 0. It's -3 because it goes X, Y, Z. It does it in the order. So transform dot position equals new vector 3. 0, -3, 0, and the semicolon on the end, so should be good for that. We also want it to move with the camera. I think I said that anyway, but to do that we could have this transform.translate. Yeah, so basically translate just means that it's going to be, it's moving, so it's transform.position, but instead of being static, so staying in one place, it can actually move. We don't want this to equal anything. Yeah, we've already done this in camera position, so we can have the variable too, why not? Okay, so int speed equals 1. So vector 3 dot up times speed, yep, times time dot delta time, semicolon, and just attach the script. So assumingly we've done this all right, the box should be moving with the camera. Yeah, okay, awesome. So the next step is we want to actually be able to move this box ourselves, because this is going to be our ship. So it's not a model yet, but we can easily switch out the prefab later. So transform dot translate. So yeah, we'll go back to 3, I think. I've not really done it like this before, because I've never actually had the camera moving with the character, so this is, it's not new to me, but the camera movement bit is. Actually, you know what, there's no point in adding on a time, so let's call this initial speed. Initial speed. Did I spell that the same? I don't know. Yeah, okay, awesome. So we got initial speed, so we'll make another variable now. So another integer, we'll just call this one speed. So equals, let's say equals 5. So vector 3 times no, not time speed, time input dot get axis, and basically what this means is we're gonna have an input from somewhere, so from a controller, from a keyboard, from a mouse, anything that's gonna move it along an axis. So basically we want horizontal. So what that means is no, we don't. We want vertical. So if we get vertical. So now if you press the W or S keys, it's going to go up and down, and if you press the up arrow, it'll go up, and if you press the down arrow, it'll go down. You can change that in the input manager, but we don't really need to. I mean, these are standard controls, so we're just going to leave this. If you wanted like an 8-degree movement on a gyroscope, you could do that as well. So that would be for if you're coding for like a smartphone. But for now, we're just going to have this. So speed times time dot delta time and the semicolon. Okay, so now we're going to be able to move up and down. So basically, to move right, we do pretty much the same thing. I'm not going to straight up show you this. Actually, this is too obvious anyway, so I'll just show you it. Instead of having this string as vertical, we have it as horizontal. I think I said that. Yeah, so hopefully we'll get no errors. Let's just check. No errors. And okay, cool. So we can move diagonally, we can move left, and we can move right, up, and down. And yeah, so that seems to be working pretty well. So what if we went off the screen? We wouldn't come back. I mean, we'd just keep going. So we could do one of two things. We could destroy the object if we go too far, and it will respawn at its point of origin. We're not going to do that. So instead of doing that, what we'll have is we'll have it so if it goes out here, then it's going to reappear at the other side. Okay, so to do this, we'll have an if statement. So ifs are pretty nice. They're basically just booleans. So it's either true or false. You know, it either happens or it doesn't. So if transform, now we can say transform.translate because we're coding in the object, so it's going to be the object that it's attached to. So it'll do this for every object that it's attached to. So yeah, so if that is less than, no, it's not less than minus 18, I think. Yeah, I'm pretty sure. Okay, we don't need a semicolon on the end of this as well because we've blocked it out. So we can have our result in here. So yeah, if that happens, if that equals true, then we'll have a result here. So transform, I almost forgot. If we just had that, then that would be transform for every side of the vector. So we want just x basically. So transform dot translate equals new vector 3 because we're essentially respawning but we're not dying. That makes sense. Vector 3. Okay, so we want x to be 18. We want y to stay the same. So to do that, we do transform dot position. Sorry, we'd also do transform dot position here. So we do transform dot position dot y, and then another comma and transform dot position z. That's also position. I don't know why I put translate there. Alright, sweet. So this should work. So we're just going to copy this script and make sure it stays in void update, by the way, just because then it'll check for every frame. So just in case the character ever goes over the line, then he'll be returned to the other side. So we flip this round, get rid of the minus, and add in a minus there. So let's test this. Okay, cool. So we reappear. As you can see, the cube kind of like drags, and it's sort of, it looks like it's expanding. It's really just because of the perspective. So we're going to switch this to orthographic. So basically what this is going to do is it's just going to essentially make it 2D. We can still have 3D objects with depth, but it's kind of restrictive. It's basically you're looking above it directly as if it was just drawn on a grid. So you know, you could still have a 3D, you could still draw something in 3D on a grid, but it wouldn't look as 3D and it wouldn't stretch if you change the perspective. So that's what orthographic is for. Okay, so what have we got? We've got the character. The character moves around, and if we go all the way out here, we do this. So you might be wondering why I've not done this for Y as well, so that if we went too low then we'd reappear. We're going to do that in a future video, just because we can't define a position on its own. We have to add it on to the position, or the new position of the camera, and for that we need a game object variable. So we'll do that at a later stage, maybe like video 3, video 4. Okay, so we've got that, and let's see. Right, the final thing we'll do is we'll write a little bit of a script for the asteroid. So C# asteroid. Okay. So what do we want to happen? So we'll just double click on asteroid, and in fact, you know, I think we'll just write the variables out in this video. So we're going to be using a random .range, and basically what this means is if you've got two values, then the range, you know, you could have anything from in between those two values. So we'll go int. In fact, no, we'll go float. Because float, basically what float means is we're going to be able to have decimals as well, whereas if we just had integer, it would literally just be a whole number between 1 and 10, whereas if we have float, I think it goes up to 7 decimal places, so it's far more accurate. And it's also far more random. So float, I'll call this right. So float right equals float right equals 18. Float left equals negative 18. Also, don't forget the semicolons. So float random pos. We don't need to assign that value because that value is going to be anything in the range of between 18 to minus 18. We'll do this for speed actually as well. So random speed. So let's go to max. Max speed equals 10. Float min speed equals 1f. And float random speed. Alright, cool. and we'll set up our random algorithm. So after you've wrote this, you can basically say to yourself, you know, that's awesome, you've wrote an algorithm. So in void update, just go random. Wait, I didn't call it that. Call it random pos. So random pos equals random dot range, and then parentheses, and left, and then just do a comma and right. So yeah, you wrote an algorithm that's going to produce a random number. It's procedural, literally. So that's how easy it can be. So random speed equals random dot range. So hopefully you're following along with this and you're understanding, and at some point you're going ahead of me and some point you're falling a bit behind. I'm actually going to do min speed here. Alright, sweet. So like with the player not being able to go below Y, we're going to do the same thing with the asteroid. So the asteroid's always going to spawn above the player, but without attaching the scripts we can't really do that yet. So we'll probably follow along into the next video, and I'll probably show you how to do that in the next video so we can wrap that up and we can get onto some fun stuff, you know, maybe like shooting enemies, creating explosions, the score system, also a GUI. I'll make a menu at some point, so we couldn't have an FOV slider, but we could have resolution, we could have an exit game option, we could have I don't know, maybe we could have light shafts. Anyway, we could have some options. So yeah, thanks for watching, guys. I hope you've enjoyed the tutorial. I hope you guys have learned something from it, and yeah, I'll see you in the next video.